All right, guys. So we are focusing on the m portion of our equation of y equals mx plus b. And more specifically, we are going to focus on finding the slope from a graph. So in the equation y equals mx plus b, we're focusing in on the m. The m in y equals mx plus b stands for many different things. We've already gone over this at the end of the lemonade problem. But I'm going to list them out here again. So one of them is the rate of change, slope, unit rate, steepness of a graph, and then the new one is when we find and count the slope for a graph, we are going to use the format of rise over run. And we talked about rise means to go up, but because we can also go down, it's the movement going up and down, which is the y-axis movement. That means run would be the movements going left and right, and that is along the x-axis. Okay, so when we're counting the slope for a graph, we're going to use rise over run, x over y. So then we talked about the four forms of slope on a graph. We said that a positive slope is going to be a slope that is going up. And remember, we said that this is when we move left to right on a graph. So a negative slope is one that goes downhill. A zero slope is a slope that doesn't rise or fall at all. So, it is perfectly flat. It's a perfectly horizontal line. So that would make undefined as a perfect line that is up and down. It is a vertical line. We said that an example of a zero slope would be the floor. It doesn't go up or down at all. And we said that an example of an undefined slope would be the wall in the classroom. So there's four different types. So we're going to move into how to actually count the slope from a graph. Okay? The first thing that you need to do is you need to find two corner points on the line. What I mean by a corner point is if this is my graph, okay, and this is my graphed line, it is where two lines, this line and this line, cross with my graphed line. As you can see on the graph over here, they've already found two corner points. It is on the graphed line where an x and a y line meet. So see how it's in the corner of that line. There are three other perfect points, corner points, on this line, okay? So I'm going to show you. This would be a corner point because it's where this x value and this y value come together. Here would be another one. And then there's one more up here on the top of the line. So there's actually 5 corner points. All right, so then once we have found 2 corner points, all we are going to use is that rise over run and we're going to count, okay? And I like to use the example of walking to Grandma's house. So I'm going to use these dots that were already there. So I'm going to use these 2 dots to count my rise over my run. First of all, the first thing I notice is that this line is going up. So that means it's going to be a positive slope. So that means my answer when I'm done will be a positive number. Okay. So then I'm just going to count how many blocks I would have to rise and then how many I would have to run to go from one point to the other. So if I start here and I go up so that I'm on the same line as that other dot, I had to rise up 1 block. Then I have to go over 2 blocks to get to the other dot. So that means I rise 1 and I run 2. So this slope would be 1 over 2. Now you can pick any 2 points, any 2 corner points on the line will work. So I'm going to use this corner point and I'm going to use this far corner point, and I'm going to show you that I'm going to get the same answer. So I'm going to start down here and I'm going to count blocks. So 1, 2, 3, 4. So I have to rise up 4 blocks. And then I have to go over 1, 2, 3, 4, 5, 6, 7, 8. So my rise would be 4 and my run would be 8. Now this third step says to simplify. So every single slope that you get, you need to make sure it's in simplest form. So if I type in 4ABC8 into my calculator, it's going to reduce or simplify to 1 over 2. And that's the same answer I got when I used the other 2 dots. So it doesn't matter which 2 corner points that you use, you will always get the same answer. So then this fourth step says the slope must be written as a fraction. So it has to be written as rise over run. As always, if you need to go back and listen to any part of that, just go ahead and rewind, but I'm going to erase and move on so that we can get through another example. All right, so on this graph right here on the left, the first thing that I notice is that this line is going down. And if it's going down, it's going to have a negative slope. So since I know that my answer is going to be a negative number, I'm going to go ahead and put the negative in the front so that I don't forget that my answer is going to be negative. And then I'm going to count the rise over the run. Again, they already found 2 corner points for us, but there's lots of corner points on this line. Okay, there's one, and there's another one, and there's another one. So there's lots of corner points. So then all I have to do is count the rise and the run. Now, I'm going to go down this time. So I go down 1, 2. Because I went down, that would be a negative 2. And then 1, 2 run. Now, I already put the negative out front, so I need to put 2 over 2. And then our third step, remember, is to always simplify. So if I type in 2ABC2 into my calculator, I'm going to get the answer of 1. And 1 is the same thing as 1 over 1. So my final answer is 1 over 1 or just 1. Negative 1, sorry. All right, so if you look at this next example, you notice that it is a perfectly straight horizontal line. So we know that this is a 0 slope line. But I'm going to show you how we can also count the rise over the run. So our first number is the rise. Well, these points don't go up or down at all. So there is no rise. But then I have to run 1 box to get to the next point. And if I reduce or I simplify 0 over 1, I'm going to get the answer of 0. But we already know it has a 0 slope because we know that a horizontal line has a 0 slope. All right, so let's look at these last examples. All right, so the first thing that you probably notice on these two graphs is that there are no points already on there. So that means that we have to go through and find our perfect points. So I always start at the end of the line and I just move down the line until I find a perfect corner point. So there's one. And if I keep moving, there's another one. And if I keep going, there's one more. Okay. Again, I notice that this line is going downhill, so I know it has a negative slope, which means I have to put a negative sign in the front of my fraction bar. Okay. And then I'm just going to count rise over run. So I'm going to go 1, 2, 3 blocks. So that's my rise. And then my run is 1, 2, and it's a negative 2 because I went to the left. But since I already have that negative in the front, all I have to do is write down the 2. So my slope is a negative 3 over 2. And you're going to want to verify that negative 3 over 2 can't reduce, but I already know that it can't. So that would be our final slope answer. I want you to try this next graph on your own. Okay, I want you to try that one on your own and see if you come up with the correct slope there. Okay. Again, if you need to go back and watch any part of this, just rewind it. Okay. You actually have one other graph on your note sheet that we're going to ignore, so don't worry about that last graph